Stars are the engines of the universe, the sources of light, heat, and the chemical elements that make planets and life possible. But every star, no matter how massive or brilliant, begins in darkness, hidden inside vast clouds of gas and dust drifting silently through space. These clouds are called molecular clouds, and they are among the coldest and densest regions in the galaxy. Inside them, temperatures can fall so low that atoms move only sluggishly, allowing gravity to slowly begin its work. For millions of years, these clouds may appear calm and motionless, but deep within them, the process of creation is always underway. A star is born when a region of the cloud becomes slightly denser than its surroundings. This small imbalance can be triggered by many events: the shock wave of a nearby supernova, the collision of clouds, the pressure from radiation emitted by existing stars, or even the slow turbulence within the cloud itself. Once the collapse begins, gravity pulls more and more material inward. The region contracts, becoming smaller, denser, and gradually warmer. Over time, the collapsing gas forms a spinning core known as a protostar. At this stage, the object is not yet a true star. It is still gathering mass, still wrapped in a thick cocoon of dust that blocks visible light. Yet inside, energy is building. As gravity compresses the gas, the temperature at the center rises dramatically. The protostar continues to grow as surrounding material falls inward, and a rotating disk forms around it, made of leftover gas and dust. This disk is crucial because it is within these swirling remnants that planets may eventually form. In fact, every solar system begins as a byproduct of star formation. The same collapse that creates a star also creates the environment for worlds to emerge. In the early stages of stellar birth, the young protostar often produces powerful jets of material that shoot outward along its poles. These jets carve through the surrounding cloud, creating glowing structures known as Herbig Haro objects, which astronomers can observe as signs of newborn stars in action. These outflows also help regulate the growth of the star, carrying away angular momentum and preventing the collapsing system from spinning too rapidly. Meanwhile, within the disk, dust grains collide and stick together, slowly building larger and larger bodies. Over millions of years, these grains can become planetesimals, the seeds of planets. As the protostar contracts further, its core becomes hotter and hotter. Eventually, when the temperature reaches about 10 million degrees Celsius, something extraordinary happens. Hydrogen nuclei begin to fuse together, forming helium and releasing an enormous amount of energy. This moment marks the true birth of a star. Nuclear fusion ignites in the core, and the star begins to shine. The outward pressure from fusion balances the inward pull of gravity, creating a stable object that can endure for millions or even billions of years. The star has entered what astronomers call the main sequence, the long middle phase of stellar life. But the story of star birth does not end there. The mass of the newborn star determines almost everything about its future. Small stars, like red dwarfs, burn their fuel slowly and can live for trillions of years, far longer than the current age of the universe. These stars may seem faint, but they are the most common type in the galaxy, meaning that much of the universe's stellar population consists of these long-lived embers. Stars like our Sun live for about 10 billion years, shining steadily before eventually expanding into red giants. Massive stars, however, live fast and die young, burning through their fuel in only a few million years before exploding as supernovae. This means that the universe is constantly producing stars of many different sizes, each with its own destiny. Star formation is not an isolated event. It often happens in clusters, where hundreds or thousands of stars are born from the same molecular cloud. These stellar nurseries can be incredibly active, filled with radiation, winds, and turbulence. The most massive newborn stars can shape their environment dramatically, blowing away surrounding gas and halting further star formation nearby, or compressing gas in other regions, triggering new waves of collapse. In this way, star birth is both a creative and disruptive force, sculpting entire galaxies over cosmic time. Star formation also explains why galaxies look the way they do. Spiral galaxies glow with bright blue clusters of young stars along their arms, where molecular clouds are densest. Elliptical galaxies, by contrast, contain mostly older stars and little gas, meaning star formation has largely ended there. The universe itself has an era of peak star formation billions of years ago, when galaxies were rapidly producing new suns. Since then, star birth has slowed, but continues quietly and persistently across the cosmos. Modern telescopes have allowed us to witness these processes with unprecedented detail. Infrared observatories can peer through dust and reveal protostars hidden within clouds. The James Webb Space Telescope has shown us star-forming regions with breathtaking clarity, capturing the earliest stages of stellar life. Radio telescopes can map the cold molecular gas itself, tracing the invisible skeleton of star nurseries. Each new observation helps scientists understand how stars like the Sun came into existence and how planetary systems emerge from the leftover material around young stars. The birth of a star is one of the most fundamental events in the cosmos. Every element heavier than hydrogen and helium was forged in stars. Carbon, oxygen, iron, and all the ingredients of rocky planets and living organisms were created through nuclear fusion and released through stellar winds and explosions. Every planet, every ocean, every living cell owes its existence to generations of stellar creation and destruction. When we look up at the night sky, we are not only seeing distant lights, we are seeing the outcome of a process that began in cold, dark clouds, shaped by gravity, ignited by fusion, and sustained across unimaginable spans of time. Stars are born quietly, hidden in nebulae, but their light goes on to transform the universe. And even now, across the Milky Way, new stars are forming in darkness, continuing the endless cycle of cosmic creation, ensuring that the story of the universe is still being written in the glow of newborn suns.